Um, Moving on to passive fire protection. Now, fire protection was probably, when we started manufacturing and selling wood fiber insulations in Europe and in the UK, was probably the most talked about topic. It was something that people thought, well, timber burns. Where's the safety? How does that work? Well, it works in a very similar way to the way CLT works, and that's through the process of carbonization. So a fire needs three basic ingredients: oxygen, heat, and fuel. If you take away any one of those three ingredients, eventually the fire will self-extinguish. And it's the way that timber structures in a lot of bases via CLT reach their fire protection level. The top surface of a material will carbonize, it essentially goes black, and that stops oxygen flowing into the product. If there's no oxygen going in, then the fire will extinguish. So other materials which have potentially the same fire rating, so for example, a glass wool material, that won't carbonize, it will melt. And by that melting process, you create a cavity. A cavity lets oxygen run through, and an unrestricted flow of oxygen means there's no way of stopping the spread of the fire. And that's part of the reason why the issues at Grenfell were so severe, because there was an unrestricted flow of oxygen. And so that's something that really needs to be thought about. In terms of fire classification, there are wood fiber alternatives for 30-minute, 60-minute and 90-minute fire protection. And that's whether you're looking at external timber cladding via render systems, CLT structures. So there's a whole raft of different build-ups and different performance levels you can reach depending on obviously the application of the building. So all of those are possible. The practical testing, and there's just some issues and some pictures here that I can show you about how that carbonization works. And you can see particularly on the picture on the right-hand side, where you have a render system with an EPS product, for example, where the fire breaks through the render facade, gets into the insulation, there's a dripping and a melting of the material that creates a cavity for oxygen, fire goes in and the fire spreads. And that's something which you can really avoid with a wood fiber. So in a wood fiber product, you can see on the main picture on the left there, you don't get that breaking, you get the carbonization of the top surface, and the fire doesn't spread throughout the facade of a building. So really good fire protection with a material that in theory has the same fire classification as an EPS or a glass wool. So they do act in different ways. And part of the processes that we're also investigating is to find out different ways of testing materials. Traditionally, a lot of the test standards are designed to really work for the more common insulations, and they don't really understand how wood fibers work. So constantly working on those test standards to ensure that they consider the products correctly is a really important step for us. And of course, what you're trying to avoid, particularly with external insulations, and when you're using EPS or XPS type materials, is that the material doesn't burn and essentially turn back into oil, which is what it's produced from.